Hello again and welcome to exam questions examples number 4 for permutations and combinations. In the first example we have Alex, Beth and Cain in a class of 8 students and we're picking 4 at random. What's the probability that we pick Alex and Beth but not Cain? So next we can write down this table showing how many ways we can pick 4 people where Alex and Beth are included. As you can see, there are 6 ways to organise Alex and Beth, but you times it by 2 because they could be swapped the other way round. We could have Beth first and then Alex. If we look at the top row, there's 1/8 chance of picking Alex and only a 1/7 chance to pick Beth. But then for the next person, we've only got 5 people left to choose from because we don't want to pick Cain. So the probability is 5/6 and then 4/5 for the last person. This gives the probability of 1/84. And if you look down the rest of the rows, you'll see that that's the same for each row. So if we times 1/84 by 12, we'll get the final answer, which is 1/7. Next, we want to find the number of arrangements where Alex is at the end and Beth and Cain are together. So first we place Alex at the end of the row and we treat Beth and Cain as one unit together. So for the next place next to Alex, we have 6 people to choose from effectively, and then 5 and then 4, etc. And this equates to 6 factorial times by 2 because Beth and Cain can be swapped the other way round. Then we do it again, but Alex is at the other end. And again, we only have 6 items to choose from for the first place, then 5 for the second place, etc. And again, that gives us 6 factorial times by 2. So the total number of arrangements is 6 factorial times by 4, which is 2,880. And then we need to find the number of arrangements where Alex and Beth are together and Cain is standing next to them. So if we write down all the arrangements where Alex and Beth are together with Cain next to them, we come up with these 4 different scenarios. And in each row, we have 6 factorial ways of organising them because there are 6 items to rearrange. So the total number of arrangements is 4 times 6 factorial, which is 2,880. In the next question, we're choosing 4 people for a committee from 5 pupils, 4 teachers and 3 administrators, and we want the probability that the committee contains no teachers. This is the formula for combinations. And first we're going to use the formula to work out the total number of ways we can choose 4 people from the 12 available. So with 12, choose 4. Putting the numbers into the equation, we end up with 495. And next we need to work out how many combinations there are that do not include teachers. So without teachers, we have a total of 8 people to choose from. 8 choose 4, and if we put those numbers into the equation, we end up with 70. So the probability that there are no teachers is 70 divided by 495, which is 0.1414. Next, we want to work out the probability that we have at least 2 pupils, no more than 1 teacher, and no more than 1 administrator. So for this, it's easiest to write down a little table. So for each row, we can only have a 0 or 1 in the teacher or administrator column, and we have to have a 2, 3 or 4 for the pupil, and they all have to add up to 4. Taking the top row, we have 4 pupils, but we have 5 to choose from. So we have 5 choose 4, and then we choose no teachers from 4 and no administrators from 3. So if you work this out correctly using the combinations formula and remembering that 0 factorial equals 1, you get 5. And working this out for the remaining rows, which I won't go through in detail, you get 40, 30 and 120. And if you add them all up, you get 195. So the probability for part B is 195 divided by 495, which is 0.3939. And for the last question in this video, we have 6 books, A, B, C, D, E and F. And first we want the probability that A and B are next to each other. So as previously, we're going to group A and B together as one unit, which gives us effectively 5 items to rearrange. And first we work out the number of arrangements of all 6 books, which is 6 factorial, which is 720. And then if A and B are together, we will have 5 factorial times by 2, because we could have A and B or B and A. So this gives us 240. So the probability is 240 over 720, or 5 factorial times by 2 over 6 factorial, which gives us 1 over 3. So to find the probability that C and D are not next to each other, we're going to do the same as before and place them together as one unit. Therefore, the probability that they are together is going to be the same as we worked out for part A, which is 1/3. Therefore, the probability that they are not together is going to be 1 minus 1/3. So the answer is 2/3. But if you prefer, an alternative method to calculate the answer is to subtract the number of arrangements where the two things are together from the total number of arrangements, and then divide that by the total number of arrangements, which, as you can see, gives the same answer. And finally, we're asked the probability that if we know A and B are together, what's the probability that C and D are not next to each other? We already know that if A and B are together, there are 240 arrangements. And if A and B are together and C and D are together, there are effectively 4 items to rearrange. So the number of arrangements will be 4 factorial times by 2, because C and D can be swapped, times by 2 because A and B can be swapped. This gives us 96, which means the arrangements where C and D are not together is 240 take away 96, so 144. So the probability is 144 over 240, which is 3 over 5. Thanks very much for watching. I hope it's helping and that I'm going about the right speed. Please like and subscribe as always. It really helped me out, and I'll see you soon.